See that? How smooth that takeoff was. Now listen to the noise of this board. This is my part 1 review of the Flipsky Dual FSESC 6.6 based on the VESC 6. In this video I'll be talking about the FSESC and comparing it to the VESC 6, and in part 2 we'll be taking it out, putting it in a board and testing it. So because I'm reviewing the Flipsky Dual ESC, I wanted to put it in a board that I felt will give me satisfaction and that I will be able to feel the difference between a stock standard ESC and this ESC, comparing what this VESC can do for your electric skateboard DIY build or an upgrade for your board. One thing I want to sort of show you is the size of this ESC. Now if we just have a look at this ESC here, this way and this way, you can see that this twin ESC, it's a little bit, just the tiniest little bit wider than exactly half of this. But what you also will see is that the heatsink is around the same size. So if we're looking at this side on like this, these capacitors are coming out the top here, and that makes the ESC quite a lot bigger actually. It's not like, you know, benefit of having a twin ESC is obviously wiring. You don't have to have a CAN bus wire going through, and also you don't have to have a wire that connects both of the ESCs to the battery. But again, in saying that, if I have this here and I do have a connector and then I curl the connector up, it's going to take up the same amount of space as having these capacitors sitting here. This does have a capacitor in there, and it's enough. It's quite sufficient for what we're using it for in electric skateboards, even a big mountain board build. But you know, it's all hidden inside of this heatsink, which is quite convenient, especially for mounting. This is the Dual ESC. It's the VESC 4.2. The reason why I wanted to show this is in comparison to this one here. Now, you know, there's reasons why this is bigger, and one of the reasons is because we've separated this power rail. It's all on this side of the board, and the low voltage, like I was talking about, is on this side of the board. But we also have 3 shunts, if you can see here, that are being controlled by 3 shunt amplifiers from the DIV chip, and it makes it a little bit bigger. But if we look here, how much smaller this twin ESC is compared to this twin ESC. If we turn it to the side, it's exactly half the size of the VESC 6. And then if we get the VESC 6, the official one, again, it's nearly half the size of one VESC 6. What I can tell you is they have changed the board layout. It's based on the VESC schematic. Now, one of the biggest things that cheaper brand VESC from China are doing is replacing components to actually cut costs. From my quick analysis on this, I would say that a few things have been changed, but the main components are the same. Now, the CSC, it looks quite nice and a good finish. That's the first view when we're looking at VESC and the amount of time that I've been using VESC for. One of the biggest things that would happen is when you would have a VESC that had incorrect capacitors and resistors, then you would have voltage spikes when motors are under load or braking, and that would actually go over the rating of the capacitors and it would cause over voltage spikes. They've included quite thick 10 gauge wire and even thicker wire on the input. Whether I think 8 gauge is really needed in this application, I don't think so. For the short distance that we're going from the battery to the ESC and the wires that most people put on batteries, definitely this is overkill. This ESC is rated for 200 amps. Now, that's 100 amps continuous per ESC or 400 amp burst per ESC or 800 amp burst. Now, the MOSFETs on here are rated to a certain amount, and it's because of the use of the heatsink, which they're saying that you can go up to these higher currents. If you remove the heatsink and the transfer pads that are in here between the heatsink block, then the current would be less. Now, whether this heatsink is actually efficient in doing what they're saying is one thing. The other thing that you need to consider is motors. Now, I don't know of any motors that I would be using this for that would need that much current. And in most applications, people over predict what their currents will be, and short spikes are okay, but when we're rating ESCs, you've got 100 amp continuous. Now, that needs to be continuous for depending on their testing, that could be continuous for 10 seconds, 30 seconds, 50 seconds. Burst is usually between 1 and 2 to 10 seconds. In every board that I've ridden at a heavier sort of weight, around the 85 to 95 kilo mark, with what I was needing to do, go up steep hills, I've never gone close to 100 amps. But, you know, usually the motor's around the 30 to 60 peak. If you were using this for an electric bike, let's say that you had 2 hub motors on an electric bike, then potentially you could get those currents. The biggest thing that I think that could be used for currents like this is in applications where higher voltage would be needed, such as electric vehicles, cars, etc., scooters. But the voltage of this isn't high enough for those applications. This is really set out for electric skateboards and things like that. So I don't think that the current on this ESC is really needed, and testing needs to be done to see if these values actually withhold. This is an official VESC 6. This is made by Tramper and Benjamin Vedder, and they have put a lot of effort into making this a good product. The big thing about this VESC 6 is that the PCB has been laid out in a way that it minimizes interference between the high voltage rails of the board. So on this side here, where you've got the phase wires and the power input. And on this side of the board where you have the low voltage, you've got the 5 volt and 3 volt passing through this ESC to power the microcontrollers and things like that. And the reason why that's important is because if you have interference between those rails in the PCB layers and traces, that can affect your field orientation control through variances in your inductance in your motors. Lots of people might ask why you would go for an official Benjamin Vedder ESC, twin 4.2 like this, or a big twin dual 6.6 like this one. You've got an ESC here that's rated for 100 amps continuous. If you want to build a board where you're only using 10 cell, you've only got motors which are not going to pull a lot of current. That means is you've got an application which there's less risk that this is going to fail. Now, Benjamin Vedder and Tramper, they do not make a VESC 4.2 product anymore, and you're really reliant on manufacturers who are still using the old design to buy this. You can get the FOC box, which you can get quite cheap at the moment, but if you're building a really lightweight, small application build, I would be buying this. This is an excellent product. I have actually tested this on the bench now, and this one here is excellent. So here, $169 US for an ESC, and I got this on sale. I've purchased all of these products. I got them on sale with a remote and a smart switch for $169 US. If you want to, have a cheap build that's going to be reliable for a lower voltage rating and low current, I think that this is really good ESC. And without jumping into territory here where Australian or even US, you're looking at $300 per ESC. By the time you get two, you're looking at $600. The reason why, as I just stated, that you would go VESC 6 over the 4.2 VESC is because you want the benefits, the performance benefits of FOC, field orientation control, and the 3 shunt resistors, which are going to give a more precise reading, allows the field orientation control algorithm to work a lot better, to get a lot smoother ride and a lot more efficiency out of your motors. Now, when you come down to it, you have to look at cost per performance. You're looking at spending $269 when this is on sale, or $330. This ESC is for those who have the money to spend and they want to support Benjamin Vedder. Supporting Benjamin Vedder is one of the most important things that as a community we could do. We would not have the VESC if it wasn't for him. Look out for me uploading part 2 of this video, where I put it in an Evolve GT and tested out the performance and do some real world testing.